Guys, this one. Oh my god. Oh! Oh. This is called mental masturbator stretch. Oh, hold it. Here. I don't know what happened. Oh my god. Okay. I think I slept bad. My iPhone needs to be charged. Shit, no. So again, one more time. Don't forget to breathe. Oof. Oh my god. What's happening? It's just the left side, baby. I did nothing. Ah! Oh my god. Okay. What do I want to do today? Code. And I want to code and I want to make you feel alright. I want to code you and I want to make you feel alright. For that, we are going to pull out the snake. Ooh. So our previous code didn't work. Now let's try a new method. Python was like a bit stupid. Python built-in functions like solve. Oh my god. My left shoulder is terrible. Research, Gaussian. Why do I have this? Benchmark, best code ever. So it was best code ever. Do we want to change it? Because now I have optimal revenue not done, which draws us this curve with a lot of which is not presentable to any journal. So we have this. Let's keep it in the same page, and if necessary, we will find another Jupyter Notebook to move these codes to best code ever and ChatGPT. Oh shoot, okay. Guys, give us a second because uh, uh, actually, I was thinking we should start having in gyms machines that help us doing the stretches. That's the best. Like everybody does everybody does. Everybody does the exercises, but for the stretch, you usually should do the stretches like on your own. There is no machine for that. Or sometimes you use like I don't know bands and stuff like that. We need to have. Oh, oh my God! This part. Ah. Anyways, numpy as np typing import list matplotlib. So this time we are not gonna go ellipse and eclipse this Monday, cubic yy, which is sigma ai omega equations, and this we have like the solution is the intersection. No, we're not gonna do that. What we wanna do is first of all cleaning the shit that we made here, because oh, it is optimal remnant. All right. I wanna run best code ever. So previously we had this R, and for the R we could compute sigma x and y, and that was it. Wait, what is lambda then? For each lambda. Wait, what is lambda? No, it doesn't make sense. So in the we fix R. First of all, we want to change R over them. So for now, for one R, we know we have this curve which is based on lambda, and we have the ellipse that they are going to cut each other. Let's assume they are gonna cut, and we want to find the intersection, right? Want to find the intersection. Okay. We want to find the intersection, and usually we want to find the lambda that makes the intersection, right? So we have, let me show you, wait. I'll be back. So this is the first part. So for each R, we have an eclipse, we have an ellipse, and we should find the lambda. So what does cubic do? Cubic gets the lambda and computes. Oh, so here we're just computing the curve, the whole curve, but we don't find the intersection. X for each lambda we have an x and we have an y. That's it. All right. Oh. That's also very interesting. Cubic val. What is val, by the way? For val in lambda. Okay. That's something very Python. Okay. What do we wanna do? Let's keep the r constant and find the lambda that it cuts the ellipse. Right? We didn't solve that. What is the ellipse equation? Is this? This is the benchmark. Revenue maximization. All right. Okay, here. Oh my god. Zoning out. Okay. This is the ellipse, right? This is equality. We remove sigma aij. We remove sigma aij. And the rest is an ellipse equation. We assume lambda is positive, therefore, do I have the ellipse equation here? Nope, I do not have it. So let's compute. ellipse. Okay, I have the formula here. Let's keep r constant for a while. 1 plus r. Okay, 1 plus r. This is r, this is mean, depends on r cubic, and we have the curve, right? We have the curve. For each lambda, we have the x and y. So for each lambda, we have an x and y. That's great. And then, just let's keep it simple for now. While, just I don't know while what, but we will figure it out later. While for, I will use for not LA in L. Oh, yeah, okay. L in NP dot range 0 to 100, and we say 1. What are we going to do? We are going to compute the ellipse and see if it is negative or positive. If so let's assume we are outside at the beginning, right? And then lambda is 0. If we are inside, lambda is 0. If we are outside, lambda is positive. And at the beginning it is we are outside the ellipse, so it should be positive. Then we are computing, we are going forward, increasing lambda until the term gets negative. 1 plus r if do. Do I have the formula for eclipse in the not BESCO optimal, but not there. Yep, cubic y equation ellipse. All right, sounds good. This to me. 1 plus r. Control C. BESCO never. Control V. So if 1 plus r over r squared sigma theta I squared over sigma theta I squared, f minus r sigma I theta I is t var sigma theta squared x minus ft sigma theta I squared, the whole thing squared, and then next line plus f minus r over r squared sigma theta I squared. Then we are going r squared, no, 1 plus r. Okay, that's right. 1 plus r t sigma t var sigma theta I squared x minus t sigma theta I squared plus n f minus r sigma omega times y s sigma omega bar squared to squared, and minus 1 plus f s sigma omega, which is s y s sigma, yep, minus 1 plus f t t bar sigma. Right, that's it. If this is negative 0 okay, no, I should use the if this shell is negative, break, that's the break rule, break, and lamb is L and break. Otherwise, lamb is 100. Okay. Or infinite. Sounds good. Print lamb. For now it's good, but let's see if okay, this doesn't work. Maybe it works. Let's see if it works or not. What is it? X is not defined. What is X? X comes from the cubic, right? Okay. Yeah. So X equal, sure, I think syntax is like that, X and Y equals cubic of L. That's it, right? What is wrong with you? Again, the code is like that? Yep, it's like that. So, guys, you have to close it for a while. And let's go over. Oh, I promise next time it happens, I will go check ChatGPT. ChatGPT. What is this? Let us know how to what my keyword word when I type in my Windows system. The next character okay, How did I write erased? Okay. Here are a few troubleshooting results. Okay, no, not this. No, it's just typing mode. No. Overtype mode, okay. Off by pressing the insert key on your keyboard. Alright. Okay, great. Solved. And now we have a good. We solved the problem. So let's try it. For example, no, this is Optimal best code ever. Okay. Equals cubic. Let's do the insert. Yep. Now let's have this and what? And insert again. Yep, we are good. Okay, x and y is cubic L 1 plus R, and that's it. Shift enter. What's wrong? So lambda is 1, which means we are already probably smaller. Let's go up to 1 and 0. 43. Well, I don't want them to show me anything for now. Now the question is how close we want the lambda. Like here, our precision is like 0.01, right? But we are good now. So now we want to use the bisection method and see if it helps. Okay, let's define an epsilon. Like bisection method is good. For example, let's assume the upper bound, we have an upper bound like 1 for lambda. We can get to precision like 1 over 1000 in 10 repetition. So it's logarithmic. Um, let's set an m and epsilon. Epsilon equals 0.0001, for example, m equals 1, and so for L, instead of this part, we should so we can put it can be anything because these are continuous. We can put this condition here as the breaking point for lambda. You know what I'm saying? You know what I'm saying? Or m can be the number of iteration. I don't know. Doesn't matter, to be honest, at this point. That's something we can invest on it later. While L, we will put it as m, while control X. So for lambda equals 0. Okay, while ABS. You have ABS? Control V. This. Because it can be positive or negative, right? E. I want to just get close enough to the so while this is actually greater than E, right? Or equal to E. What do we want to say? We want to say oh my god, my back is while what do you want to do? So we try 0, and we have this interval of 0 and m, right? This is 0, this is m. We try 0, it is greater than epsilon. Can you see? Yeah. So the situation is that we start from 0 and m, but I want to write the code in a recursive mode, right? We have 0 and m. We probably try the middle point, right? We want to, okay, m, for sure we know m is negative. And for 0 we know we are positive, right? Inside, and for this we are outside, right? What we want to do is just compute the middle point, a plus b. If a, b, right, we have this curve, here is a, here is b, which is negative, here is positive, we choose 1 here. Okay, the thing is that we compute a plus b over 2. If both a plus b over 2 is positive, we keep b and a plus. If it is negative, we keep a and a plus b over 2. So that's a good thing, actually. Oh my god. So let me set a equals 0. Let's assume it is positive. B equals m. Let's assume it is negative. C, we call it a plus b over 2. And what else? We want to say so a is always negative, a is always positive. If so a is always outside and positive. B is inside and negative. So if C is negative, we choose A and C. If C is positive, if C negative, we choose update by What are we updating with? We are updating with A and C. If C positive, update update C and B. That's it. So update C and this. By C positive and negative we mean ellipse of C, right? If x and y will be cubic of C, if this control X, control V, okay. If this is negative, okay, I want to say minus of C. Doesn't matter, to be honest. If this is negative, what do we want to do? We want to say C negative, put A and C. A equals A, C equals B equals C. If this is equal 0, just C, return C, break. If this motherfucker greater than 0, we choose C and B. B. Then we should repeat this whole situation here. Oh, let's put a name for it. ellipse. If ellipse. Less than 0. Okay. So we want a while. Doesn't matter, to be honest. While b minus a less than greater than epsilon greater than e. That's a good criteria. Where is my e, by the way? Okay, we have it. And yeah. Then, okay, we found our C. That's the C we wanted, the lambda we wanted. L, I want to call it C because it's lambda. Beautiful. And then what do we want? What we want is the curve. Oh, we want to plot it for different values of R now. So let's do this again. Let's see how it goes. This is best code ever. Okay, what is L? Print L. Why did you jump? Oh, it's so close. Good, guys. We are very close. So let's assume it's good enough. And we have this. Now we want to do this code for different values of R. What do we want exactly? We don't. X and Y is cubic of L. Yeah, we want X and Y. By the way, what is the range for R? Because here we assume R is negative. Yep. For R negative. We're solving it for R negative. And what are we plotting? Based on lambda. Based on C or lambda. Right? No, based on R. We are plotting them based on R. Yep. for r in np.arrange what? -1 plus a and minus e, and what is the, I don't know, 0 point. That's good. Every time, like, yeah, let me put this stuff inside the for. Yeah, well, maybe it's smarter, like, once r changes is small, you say a and b are pretty, but we don't know if a and b are both negative or positive. We can, maybe it gets more efficient, but who cares? We are not here for efficiency. Yeah. We just want a code that works. That's enough for me. And x, let's say xx equals infinite array empty yy equals infinite array empty. Maybe if I like the code, I try to use like a one-liner lambda function. Anyways, like we have here, you know, like this. I don't know this one, by the way. Where is it? Nope. This lambda x. Nope. For val in, I don't remember. We had somewhere. Probably I deleted. Okay. Then what we are going to do here is we get out of the while loop and we wanna XX doesn't have append. How to append? So engineer optional. np.append. Okay. What is different? Oh. Right? Now we wanna plot. Matplotlib, how do we plot? I want to know the syntax. So print, no, not print, plot, matplotlib, plot, show plot, I don't know, what is it? So we say plt.plot of your x variable and y variable. So plt dot tab, you can say plot, plt dot plot. What is x? Can I say r and xx? What is again? Plt dot x label, plt dot y label, and plt dot show. Okay. Plt dot show. Okay. Nothing. What? Oh, maybe it's taking time. I see. How do we know if it is running or no? Okay. What is running? Okay, this is just a size. Oh, we have it. What the fuck? Wait, what? Second. Like, it's not like MATLAB that we have a cursor and go over the numbers. How can I open a new insert? Cell below, print, XX. So they're like big numbers. So it's very big at the beginning and it becomes very small. Well, this is not this plot, by the way. This plot says something else. By the way, this plot is only right up to R positive, R0. What's wrong with it? This sounds better, to be honest. Okay, one thing we can see here is what are the values of C, by the way, the lambdas. I want to see the lambdas too. PNT dot plot leave plot PNT dot show. Okay. Let's write it PLT dot plot. The NP dot range is already there. So it is positive. And it's not like very small, by the way. What is this line? Oh, I should also do the PLT that show. Okay. Lambdas sound nice. Look. How does Y look? Oh, Y looks good too. Just X has problem. Why is X like that? Because, well, for y you need to have a nice solution, right? So if y, what is y, by the way? Y is this beautiful function, comes from here based on lambda. Lambda is x's problem. X is the root to this motherfucker. Oh. Okay. We fixed r here, we forgot to change it. That's why. So now our cubic takes two value, L float and R float. R float. Now cubic of C and R. That's it. Let's kernel. Alright. Good, we found it. R0 is not defined. Okay. A. This should also be changed. Bring it here. Control X. Where does it show up? By the way, I don't know. Mean A. Where do we need mean A? By the way. We need mean A for what? If there is somewhere it should be here, but I don't know where we used the mean A even. Oh, it was in the equation. It is in the cubic. Right? Cubic coefficients. There is no mean A. It has mean A. Okay. So mean A is here. Running code with snaps and whistles. What the fuck? Again the same shit? How didn't it change, by the way? It's previously R we saw, Jessica. Now cubic defense. It's kind of strange because previously our cubic was something here. Maybe just no. So we wanna keep our intervals length this is small, which is very good. But this one gives us x as this. Let's see if y is similar. Uh, so is this y similar to the y we have? Also, what is the values of lambda? What is z? Z lambda? Yeah, it sounds z is lambda. Why didn't I introduce them here? This is the ellipse. Ellipse doesn't have cubic at z. So z, yeah, print L for us too. Oh my god, this is terrible. This code is terrible. This code is good except -1. Print. What is wrong? Invalid. Which one is a scalar value? XX, sorry. So it is only -1 that is acting weird. 10. Okay. Three. This is also 3. Okay. 2. 2. I see. So it's just 1. The 0 has problem, the rest are good. 6,000. 2. So big at the beginning. It's just 3. So it is still login. It has this exponential form. Like if I say 10, still. So it is smooth. 100, not 20. Got me. 20. Okay. Yeah, it's just a very exponential thing. How can it be exponential though? It cannot be exponential. It sounds very exponential, but it should not be. Why? Because, oh, maybe it's just something based on 1 over r plus 1 that makes it so big. 50. If I say 50, how does it look? So it is very smooth curve. If I say 100, 100. Okay. Doesn't look like that. Well, yeah, 1,000 point. I see. That's what it is. Okay, let's make sure of one thing else too. Let's sure both of them are positive and negative, which sounds they are, like it's like a self-fulfilling prophecy. Uh, what does ellipse takes as input? R, X and Y. Okay, let's make sure we are also clean on this part. What it takes is X float, Y float, and R float, and it gives us nothing special. computation here before getting into that. Something similar to here. From V. So F. What's happening? What's happening? So we want to make sure that for A we are outside, and for B we are inside. Let's make sure here. Control V, X and Y is cubic, A and R. If ellipse of, okay, X and Y, if ellipse of X and Y and R, not R, okay, right, positive. So let's do that. B R less than 0. Right? So that's it. Else print B is not big enough. Print what? That is not big enough. Print print that's it, right? Else if for A it's not positive, it means that solution is not deterministic. But for R negative, we know that we are deterministic, or we don't know. We don't know. Yep, we don't know. Where is it? Else. Print. Inner point, interior point. And yeah, print R close. By the way, I don't know the Darsat F formula, so we are gonna learn it. R. Let's remove this shit here. Wait. Okay, you should not put the name of the function as makes sense. Get it? What is this? I call it ellip. This one is bullshit. This one. This one we don't need it here, right? Both of them we don't need. So we got C and R. I don't know. Let's call it K. Oh shoot, okay. It's running the code. Takes some time. When it is running the code, what is the color? Okay. Somebody's family name is Everest. Um, Let me do it from the beginning. So it is the same thing. Um, okay, that's what we are going to do. Uh, Take a break, check the code again. Maybe it is the right answer. And then we come back. If we find a mistake in it, we correct it. If not, we email Thibaut to show them the result. Sounds good. Thanks guys for being with me. I really like this session.